Hi, welcome back to this fifth video about Speakerbench. And this time we have come to the part about the box simulation. We have a visible button here for box simulation, but as I will show you, when you click here you can't really load any data from the box simulator itself. You have to do that from the previous application, the datasheet creator. But let's click on the box simulation button. So here we are, and this is a beta. We have added this feature to Speakerbench because we figured you've gone through all the other steps and you have created a data sheet, and what do you do with it? And I guess there's very few options right now, but we hope that there will be lots of simulation applications for speaker design that will support the import of our data sheet. But for now we did this thing here, and it's not a complete design tool, but it's our input, you could say, and we think it's a useful tool the way it is now, without being complete for designing speakers. Yes, normally in Speakerbench at the top you have an area where you can upload your data, but in this case there is no such thing, and there's no driver loaded into Speakerbench box simulation app. And to do that we have to go one step back, and up here at the top we have these icons. You can choose the data sheet. Here we go. And the idea with the datasheet creator is that you come from the previous sessions and you have a fit and you upload a fit, and then you can finish the datasheet here. But you can also upload a readily available finished datasheet, the SBD file. So let's do that. We can assume that you have measured your own driver and you have your own SBD file, and you pick an SBD file like this one. And you just plug it in here, and now it's loaded. And on this status bar you can see what's loaded, and it's in this case a CS L16 driver. It's advanced parameters, which means you have a viscoelasticity and also an advanced inductance model for it in this description. And this is what the general tab looks like. When you fill out the data sheet you have to fill out the red boxes, but in this case it's already done, but you can change it if you like. Here's the advanced parameters, and also the diaphragm area, the shadow area of the diaphragm. So, and in the simple tab we have till small parameters. They are all gray boxes because they are calculated. But you can add an X max value, and in this case it's 6 mm. And you have a JSON summary that shows you a summary of the driver parameters here. And that summary is also available from the box simulator, by the way, so you don't have to go back here and see, hey, what was the driver parameters. They are this summary is also available in a tab in the box simulator. Okay, so to get this information into the box simulator, it's already stored in memory. We just click on the box button up here, and as you can see it loads up the driver, and other than that there's no information about the driver. But we have this driver tab, and like I said, here's all the information in case you need to know. When you load it up, Speakerbench already initializes some input here in the box simulation. Like the volume of the box is here 12.8 liter, and it's just the VAS of the driver that it copies in here. And it simulates by default a ported box, so there's a port tuning frequency here, and it's initialized to the resonance frequency of the driver. Both of these are kind of dumb. You probably have to change it, but it's just an initialization. And as always, all the apps are kind of top down, so there's a top line with the box Then there's a little bit more of the box volume here, and then comes the port information, and that's what we should leave for another video. So, but it's initialized now, and we get an information page which tells you a little bit about the reference efficiency of the system, the Q values of the box, and the absorption Q is infinity by default. And then you have some mass loads here and a fill in gram if you add damping material. And then you can see that the Lx is the width of the box, is 23.4. Ly is the height of the box, it's also 23.4 centimeter. And Lz is the depth of the box. And it's all the same, it's a cubic box by default. You can change the ratio between these in the settings tab. And then there's a port length of 21.1. So there's only like 2 centimeters from the port to let's say the back wall of the box in this case. Yeah, and then there's the driver, we saw that, and then you get an SPL response, and you have here a port output and a driver output, I mean, that nulls at the port, and then you have a port output that comes up here, and it sums up to this dashed line, so that's your response. And then you can see that there's a vertical line here called box mode, and basically based on the Lx, Ly, and Lz, it calculates where will the box mode be, and it's here in this case 733 Hertz. And the point is that above this frequency it's going to be riddled with box modes, and you cannot really trust the simulation anymore. So the simulation is only really good below this frequency, below this bar. And we have an SPL box that just shows the box sum. That can sometimes be nice, just to see the sum without all the confusing lines. And it has a little added feature here that if you put in an Xmax value, it's not required, but if you do, Speakerbench will calculate an Xmax limit. I can show later how that works, maybe in another video. And here's an impedance response, the excursion, and since we are only playing at 2.83 volts, so that's 1 watt, there's not a lot going on. We are below 1 millimeter here, and then it comes up a little bit. So it's definitely in a linear range where we have an Xmax value that was input in the datasheet, so we have this line here. And if you did not put an Xmax value in, there will just not be this guideline will be missing. Velocity, this is the port velocity, and at such low power, of course, there's only like a little bit here, and we have put in a limit here, a guideline at 15. It could have been 20, but I mean, it's just a guideline. Don't take it as something very accurate, you know. And then there's a delay. This is the group delay, and we can see that below 50 Hertz it comes up here, so this is going to be a little thumpy in the bass, and my recommendation, the way I work with it, is that I try to get a linear frequency response, and I would like to keep this group delay below the guideline to give it like a nice impulsive response, a nice impulsive sound in the bass. And yeah, but Speakerbench did not try to optimize this. It just puts in the VAS and the FS value into the box parameters, and you have to kind of find your own way. And then there's a step response here, and this plot you need to activate with a time domain toggle. So here it is, time domain toggle, and you activate it, and then you push apply, and then it'll take about 5 seconds, because that's quite a heavy calculation to do that in the time domain, but here we are, and then you can see the step response. So this means that you are on the input side, you apply like an input voltage in a step, and then of course the output from the driver moves out. It has like a pressure response that comes up, and then it has this settling time here. There's a little thing going on here in the beginning, I know. Someday I'll get around to fixing it. And below it you can see a pole zero plot. This is probably for people who are especially interested, but when you do the calculation of the time response, you integrate in a way here in this pole zero plot, and in our case it's a fast algorithm that is a contour integration that follows this line by my cursor, and you have to avoid that you get in conflict with the poles. So that's the trick here. But it's for people with a special interest, I guess. So that's why it's hidden down here below. But here is the step response that some might find useful. And you got like an introduction to what the box simulation can do in Speakerbench. Thank you very much for watching, and please remember to sign up for our YouTube channel if you like.